Давай.
Okay, we'll try to solve some Hackerrank challenges. Today we will start with the warm-up ones. Had solved just a few of them just to see how it works. It not took too much time for like finding how to run everything and so on. And by the same time I will explain what we do in JavaScript, how to how to solve such type of problems, challenges, and how we need to think about them, like what techniques exist to solve the problems and so on. First of all, we will not focus on the coding itself, but we'll try to solve the problem like by ourselves, by trying to understand what should be done and how we as a human will solve this task. So without algorithms, without something, but we will try to just describe what need to be done. So very important is to find in the task things that are not important. So to split the things that matter something and that doesn't matter anything, because very often tasks have a lot of additional information that is not required for solving the task itself. So let's start with this warm-up challenge and see how it will go. Gary is an avid hiker. He tracks his hikes meticulously, paying close attention to small details like topography. During his hike, he took exactly n steps. For every step he took, he noted if it was uphill or downhill step. Gary hikes start and end at the sea level. So it means that it's level 0. And each step up or down represent 1 unit change in altitude. Just imagine his steps if he like move for every step 1 meter up or 1 meter down. It's nice steps. We define the following terms. A mountain is a sequence of consecutive steps above sea level, starting with a step up from a sea level and ending with a step down to the sea level. A valley is a sequence of consecutive
steps
below sea level, starting with a step down from a sea level and ending with a step to see a valley. So we have two types, or we go down and up, or we go up and then down. Giving Gary sequence of up and down steps during his hike, find and print number of valleys he walked through. For example, if Gary pass is down, down, up, 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 down, down, he first enters 2 valley units deep, then he climbed out and up onto a mountain 2 units high. Finally, he returned to sea level and end his hike. So I think there was an image. Yes, like okay, it's the image for something else. Let's continue for now. So that's description of like what we have at the start. And then we have function description, which will describe how we need to implement our function. Complete counting valleys function in the editor below. It must return an integer that denotes the number of valleys Gary traversed. So we need to count only valleys. Counting valleys has the following parameters: n, the number of steps Gary takes, as the string is describing his pass, so it will be 2 letters, down or up. Input format. The first line contain an integer n, the number of steps Gary hike. The second line contains single string of n characters that describe his path. So this is simple input. We will have 2 lines. First line represents count of steps. The second line represents the steps itself. Generally, there is some prepared code. It's prepared by the platform itself, so we don't need to worry about.
Please wait a minute. I have some problem with video from you.
Okay.
I now see some artifacts. I don't know what is this. Can you stop and start again sharing your desktop?
Yes. Does it help? Okay. So on this platform, we already have some prepared code that will read the input itself and pass it to our function. So we have this function counting values, which we will need to fill with our code. Our code is here for just put everything in this function. So to read the string, to parse it, and to put everything in this function, so we will not spend time of additional things but not solving tasks. So what constraint we have? Most of the tasks is about some constraints and not the just solving tasks. So we have some kind of limitation. First of all, our memory on our machine is limited by some amount. The CPU time is not like a limit, but we want to solve tasks like right now and not in the like 5 years or something like that. So our algorithm should be fast enough and consume not a lot of memory. We will also learn how to calculate both of these things. So the number of steps is minimum of 2 steps. So for example, up and down or down and up. And maximum of 1 million steps. Every steps is up or down. No other options is provided. And for output, we need print a single integer that denotes number of valleys Gary walked through during his hike. We have this simple input and output will be 1. And we have explanation here. We will represent dash at the SSC level and step up as I don't know how they call backslash and the second one
front slash.
front slash. Okay. And step down. Gary's hike can be drawn as like this. So he go to the mountain, he return to sea level, then he go to valley.
I'm sorry, it's called just slash. Backslash and slash.
Okay. Nice. So he have a pass only one valley during his trip.
During his pass.
During his pass, okay. So first what we need is to try to understand how we want to solve this problem by ourselves. Can you try?
Okay. What should I do? I can just write every step by a single operation.
Okay. Can you tell it like out loud by yourself, just to tell what?
Can I see the code?
We're not talking about the code. We have
Ah,
some
okay,
sample input. We can start with this
okay.
sample input, for example.
Gary uh, is going. Show me the pass.
Let's try with this pass that was
Okay,
on the start.
Gary is going down. It's the first line. Second line, Gary is going down. Third line, Gary is going up, and etc.
Okay, uh, we need to count a number of volleys. So the number of times he goes below the sea level. How we can count this? Like when we start to count this.
I'm sorry, this video artifact starts again. Can you again stop sharing and start again? I don't know what happens.
Okay. Skype happens.
Ah, Skype. Thank you, Microsoft. So repeat please the question again.
We need to define when volley start and when volley ends to count them properly. So how we can define that volley starts?
I think we can.
Let's go with this one. With this one, it will be easier since we have like an image.
Well, every step is a one unit.
Yes.
Maybe if we if so we can write that Gary's move is one unit. We somehow can define this, and when he stop moving, he made one. He goes through one valley, and we somehow can describe it.
Okay. Here we have valleys and mountains. What the difference between valley and mountain?
Mountains we go up, and valleys we go down.
Okay, so the thing that we need to check first is when the level is changes from 0. So we can ignore all other changes. Everything that is changed we can ignore, but we need to do some action when the level is
Change.
was 0 and then is 1 or -1, for example. And if it goes -1, we can increase amount of valleys, and if it goes +1, we can increase amount of mountains. We don't need mountains in this task, but we can count them just in additional. Why not?
So we can check if 0, we do nothing. If 1, we go up. If -1, we go down.
Right. And if it changes exactly from 0 and not from, for example, if we go from -1 to -2, it doesn't mean that it is additional value. It is the same value. So the only meaningful thing is like when it changed from the 0 level. So we have 0 level here, and we can have 1 up. That means that from this point, mountain starts. When it returns to the 0 level, it means that mountain ends. On the next steps, we have -1. That means that valley starts. And we have another -1, but we ignore it since this level was already -1, and other steps it doesn't matter for us before it will not return to the 0 level. And all steps here is just steps that beyond CL level, and they doesn't matter for us. But after these steps, we go back to 0 level, what means that this volley ends. So, first of all, we will have something that will represent current level of the mountain or valley. We'll have some number that we will increase and decrease. We will check if it number 0 and then it change for something else. But generally we can just check it if it's 1 or no, we cannot check it if it's 1 because here, for example, we have like -1, but it doesn't matter. So we will need to check like previous step where we was and the next step. So we'll need to count 2 steps. So let's start to represent it somehow in our code. I prefer to rename the arguments we have here from just 1 letters to something meaningful. So n is steps count. Steps count. Let's call it exactly like this. And the second variable, which is s, represent a string of steps. Steps string. Let it called like this. So we need to go through the step strings and check every symbol, is it U or D, and by this we will increase or decrease some count. So we can create few variables like mountain count will be 0 initially, valley count will be 0 initially. Generally, it's not good to count things that are not required by task, so let's doesn't count the mountain. No one asked us to do this, so we will not do this. And current level, which start from the sea level, which is 0. So we will go through the step strings. We will start from the first symbol and we will go until the last symbol of the string. And we will see what we have currently. So this string is something like an array. It's not an array, but we can access every symbol like from array. By this, we accessing current symbol, so it will be U or D. So we need to check if this U, then we go up. Otherwise, we go down. So if we go up, we increase current level by 1. If we go down, we decrease our level by 1. Right now, everything is clear?
Yes.
Okay. And at the end, we will need to return valley count. Right now, we doesn't change this number, so it will return 0. And the problem will be not solved. Also, generally, when you solve such tasks, there is some, I just want to explain a few additional things. There is few cases, for example, if he will not return to the sea level, what we need to do. And generally, there is some explanation like we need to throw an error or like return 0 or doesn't count the last valley or mountain like since he doesn't complete this trip to the end, like we doesn't count the last one. But since this is like warm up and simple tasks, there is no such limitation, and we always get a proper input. So in additional, we will save previous level. Let's do it like this. Previous level will be 0. And before change current level, we will assign to previous level current level. Maybe it can be done without the second variable, but let's do like this for now. So
Alexander now don't explain about programming. He explained the logic when you
try to solve this
strive to solve this problem. Yes, so he will not go deeply in programming.
For some cases later on, I will go more deeply to some programming details, but right now is like super beginning things like using variables or using cycles and so on. I don't want to explain such things since you already knew this, and for the people who will learn, like it's the first thing that they will learn anyway. So we will save previous level and then change current level. So at this line of code, and for two line of code, we have previous level and I have current level. And right now we can do like this. If previous level is 0 and I think we can put other logic inside, since if it's not 0, all other things is not matter a lot. And current level is greater than 0. Generally it doesn't matter, since we doesn't count mountain itself. The other only below 0 means for us something, so let's combine it from initially. So if previous level was 0 and current level is below 0, I can generally compare it to -1 and it will be the same, but I prefer for such comparison using greater or less signs, since sometimes in code you can like change this logic later, for example, to have 2 steps. 2 units per steps and so on, and this string will fail. So in this case, we want to have like some better logic that will able to handle other changes in code later on. So and we will just increase count of values by 1. I think at this moment of time we can run our code and see how it will work. So we run our code and our test cases goes well, but when we will submit code there will be much more test cases and something can be fail. So first it run this simple code that was initially. Let's go with our code through this example. Generally I can just copy it copy it here. Yeah, like this. Oh, 1 second. Like this. So we start with 0 level and it doesn't count anything. I mean, it doesn't represent any step. First step is U, so we increase our current level. No, sorry. We start with this one. And we assign to previous level 0. We increase current level by 1, and then go to condition. Previous level was 0, but current level is greater than 0, so we doesn't increase volley count. Then we go down. Previous level was 1. Current level is D, so we go -1. So current level is 0. So in condition we have previous level not equal 0, so we also skip this condition. Then we go also down, but on previous step we have 0, so it was 0 and go for -1. This condition is match, and we increase volley count by 1. So that's generally all. So, and it's like repeat until the end and everything is fine. So let's try to submit code and see that all test cases that this platform has work well.
Wow, you're a great programmist.
Yeah. So the next thing, that's not the end for this task. We need to do two additional things. We want to count how many memory will consume our code and how optimized it is. Generally, we will not count exactly how many memory will consume our program, but how this memory will grow depending on the number of steps. So, like, what if there will be not million but 1 billion of steps? How it will affect our memory consumption? How it will affect other things? Generally, we will talk only about how fast it grow. So, for example, in this case, we save 3 variables. 3 variables doesn't change. I mean, the amount of these variables, it doesn't change by the length of the string or by this number. So they are always 3. So we can tell this amount of memory consumed here is 1. It's not amount of bytes or something. It's like just a mean that it's constant. Like it will be always the same number, not depending on the length of string. Is it clear?
Mm-hmm.
Now we go for the cycle itself. Let's go inside the cycle. We still have just one variable here, so it doesn't change memory consumption. It will be still 1. We have condition that change current level, so it will be 1. And through last thing, when we change volley count, it's also just a single variable. So by memory consumptions, we have only 3 variables that we assign, and we doesn't add any additional data structures or anything that can consume memory depending on amount of steps. It will be more clear on later tasks, since right now we doesn't create anything too complicated. So right now memory it calls space complexity. So space complexity will be 1. Why it 1 and not 3? It because 3 also means 1. Any
Great explanation.
yeah. uh, we can drop any constants from our formulas and leave with just one. For example, if there will be like 5 of variables, it doesn't change anything. It doesn't change amount of memory consumed by the incoming data, because it's like it will be always the same number. It doesn't matter, is it like only 2 steps or 2 million steps or 2 trillion steps or whatever. Then we need to see how many steps our code do to solve the problem itself. Assign variables is generally also have complexity of 1, but there are some cases then it's not 1, we will cover them later. We have an cycle here which go through steps string, so complexity depends time complexity, it's called time complexity. Time complexity means how many time this code will took to run on our CPU or whatever. So here we have time complexity of length of string. So step string's length is our time complexity. If we have 2 steps, then this code inside here will do 2 times. If we have 1 million steps, this code will happen 1 million times. If we have 1 billion steps, this code will run 1 billion times. So the more steps we have, the more times we run this code. Inside the code, we also doesn't have anything complicated. So assigning variables or just if condition without any special checks is just complexity of 1. So it doesn't change the complexity of the cycle itself, and we have only this. So time complexity will be hey. So I will continue an explanation for now. Generally, if we have something like this, initially it represents like some letter like n. So we have complexity of n. So space complexity will be 1 and time complexity will be n in this case. Hey. Okay, I think for today, for like first start, this is enough. Since we have some technical problems, that will be all for today, and we will continue tomorrow with some other task.